Thousands of Go projects depend on one TOML parser. It's a decade old and it's good code. We rewrote it in Rust and found 18 bugs in the original. The rules were simple. Same spec, same test suite. 775 conformance files, and we weren't allowed to touch one of them. A lexer, a parser, an encoder, and an error type that knows where it is. 4,000 lines of Go became 1,800 lines of Rust, with nothing in the core but the standard library. The corpus is stranger than it looks. It holds two versions of the spec side by side, and they disagree. One file says a trailing comma is fine. Another says it's an error. Same syntax, opposite verdicts. You can't pass both. So you pick a version, the one the original targets, and score against that. 218 valid. 492 correctly rejected. 710 out of 710. Then there's the 18. Files the suite marks invalid. TOML that should be rejected. Go accepts them. Same bytes, both decoders. Go exits 0. The port exits 1 and tells you the line and the column. Comes down to one variable. Go tracks whether a table exists with a single Boolean. But a table can come into existence 7 different ways. A header, parent of a header, an array of tables, a dotted key, an inline table, and a Boolean tells 2 of them apart. So the port uses an enum instead. 7 variants, 1 per origin. And every rule about whether a table already exists becomes a single lookup. Passing a test suite only proves you pass that test suite. So we built a differential fuzzer. Mutate real TOML, feed it to both decoders, compare every value that comes back. 1,100 iterations. 0 disagreements. It did find 3 bugs. In ours, a float exponent that overflowed to infinity. A carriage return that could start a line continuation. An inline table whose keys got read as values. None of them reachable from the suite. All fixed. 0 unsafe. 0 dependencies in the core. 19 decisions written down. And a parser that ends up stricter than the one it came from.